All right, in this section, we're going to start the topics of probability. This is when the course is getting more serious. This is the introductory stuff was just to get used to data acquisition. Here we're going to start looking at the mathematics and the theory behind the numbers that we get. So we're starting off with terminology. There's quite a bit of it. I'll write them down one at a time. So let's start out with an experiment. An experiment is a planned occurrence carried out in a controlled environment. We're going to start with pretty basic examples. So some examples of experiments would just be things like flipping a coin, roll a die, let's see what else, drawing a card, furthermore, the experiment is by chance if the outcome is not predetermined. And all those examples that I gave, we could say are by chance, unless I happen to know what cards are available to me. It's still a matter of chance, though, because I'm only going to grab one card out of a collection of cards that I don't see. Rolling a die is a chance, unless the die is fake or has been worked on in such a way that certain numbers come up more often than other ones. But in this class, we're going to assume things like coins and dice are all fair. That means that any number between 1 and 6 is equally likely to come up. Or when you flip a coin, a head or a tail is equally likely to happen. An event is a collection of possible outcomes of the experiment. So as a quick example, I can say the event is roll a die. So actually that's my experiment. So, and then the event could be an even number. So you see the event has the items in it 2, 4, and 6, while the original experiment has any number of these available to me. An event of only even numbers is 2, 4, and 6. The result of an event is called an outcome. So if I flip a coin, for example, and I get heads, well, heads is the outcome. the sample space is the set of all outcomes possible for an experiment. So as an example, once again, if I roll a die, we'll use the letter S for sample space always. So we have S will equal, the outcomes are 1, 2, 3, 4, 5, and 6. Flip a coin. Sample space for that is just going to be heads or tails. If you draw a card, then there's 52 possibilities in a deck of cards. Another thing we could say about an event is any kind of possibility. An event is just a collection of outcomes. Notation. If A is an event, P with A in parentheses is the probability of that event. Properties of probabilities. So properties so these are general properties that probabilities have. We have probability will be between 0 and 1. That means the lowest possible probability is 0. So if I have P of A equals 0, that means that A cannot possibly occur. On the other hand, on the other extreme, if the probability happens to equal 1 or 100%, that implies that A is guaranteed to happen. If you have something like this, A is just as likely as not to happen. Because the probability of it not happening also happens to be 1/2. So like when we flip the coin, for an example, we have, let's flip a coin. So we know that the sample space just has 2 items. It has heads or tails. So then this will be, I guess you could call it a definition, but the probability of getting heads is the same as the probability of getting tails. That's what we're going to insist, that we have a fair coin here. So they're the same. That means the probability of getting heads is the same as the probability of not getting heads. So that means that we have the probability of either of these things happening is 1/2. And this should make sense because look here, we have 2 items in the whole thing, right? If I want to know heads, how often does heads come up? Well, it's 1 item out of a total of 2. So 1/2. You may, if you want to, you're not going to be required to do fractions, but they will pop up occasionally. You may just want to go like this, 0.5, like so. Now, if you roll a fair die, we know that there are 6 equal possible answers for outcomes that can happen. So the probability of 1 is the same as the probability of a 2, same as the probability of a 3. So let's put that down. Roll a die, a single die, so that the sample space is anything from 1 to 6. So the probability of a 1 is the same as the probability of a 2, all the way up to the probability of a 6, and that's all equal to 1 out of 6. You could even do something like this. Inside of the parentheses, you can put more descriptive things in there if you want. So I can go, what's the probability of getting an even number? Well, since these are equally likely, look what we have here. We have a total of 6 items, so I'm going to be total out of 6. And there are 1, 2, 3 even numbers out of there. So 3 out of 6. Or if you want to go with decimals, 0.5. As mentioned, unless said otherwise, we're going to insist that all coins and dice are fair. The word or is important in this course. So we're going to roll a die again. So when you roll a die, we know that the sample space is 1 to 6. Now I'm going to let A and B be events. And furthermore, I'm going to tell you what they are. A is the event of getting any one of these 3 numbers, and B is the event of getting any of these 3 numbers. So the OR operation is meant to join together the sets A and B to make a bigger set. So here's what, I'll write it and tell you what it's about, and then we'll get the definition below. So when I write this, I want all the items that are combined totally within A and B. And not only do I want all of them, but I don't want to list them more than once. So I want to list each item 1 time. So the way I do this is for A, I put 1, 3, 5. I've got all the items from A first. And then I look in B to see if there's any items in B that I have not already put in yet. So when I look here, I notice that I have not put the 2 in yet. However, 3 and 5, I already had those. So this is what A or B looks like. And then if I want its probability, well, there are 4 items in this event out of a total of 6 items. So when you write this, A or B, that equals the outcomes in A with any additional outcomes from B. All right, the next important concept, and So I'm going to use the same, I'm tell you what, I'm going to get rid of this. Since I'm going to use the same A and B for all that I'm going to do, if I have A and B, if I write this, I want all the items that are in both A and B at the same time. So if we look here, I see that there's a 1 in A, but 1 is not in B. Now I see that there's a 3 and a 5 in A, and that there's a 3 and a 5 in B. And those are the items that they have in common. So we would write that as the answer, 3, 5. And the probability of A and B equals 2 out of 6. Or, if you want to go decimals, 0.3 with a bar over it. So A and B equals the outcomes that are in both A and B. The next important topic, complement. Complement is the things that are not in the set. But now, when you have a sample space, like I have here, as long as I'm doing this problem, this is the universe of my numbers. This is everything that is in my universe while I'm still working with this problem. So my sample space only has 1 through 6, and A, notice, has 3 of those items. When I write this, I say at A prime, these are the items that are not in A. So come back up here. Let's find out what was in A. A, it looks to me like A was all the odd numbers in all the odd possible answers that could come up, or numbers that could come up. So then its complement would be the even numbers. So we would have there 2, 4, and 6. Of course, the probability of A prime equals 3 out of 6, or 0.5. And so A prime, the definition is the outcomes not in A. And another thing you might want to know, the probability of an event plus the probability of its complement equals 1. So I can show you real quick. We saw that P, the probability of A prime, is 0.5. Well, the probability of A is also 0.5. So they just happen to be the same, but they do add up to 1. Conditional probability. The notation looks like this. P, and then I'll write something like this. A vertical bar B, or A slash B, or whatever. This equals the probability of A and B. This is a formula that you're going to want to write down and keep with you. You'll be allowed a formula sheet for your test, so make sure you make a good collection of notes with formulas here, and we'll divide by the probability of B. This little slash B is supposed to make it seem like that. Now, if I'm going to use the same numbers that I've been using from before, let me find the probability of A and B. That up here was equal to 2 out of 6. And the probability of B was 3 out of 6. Now, you can do this using your calculator. I'm not insisting that you do fractions, but you may want to remember that the way you work these fractions is to take the reciprocal of the second one, cancel these, and you'll get 2 out of 3. You could otherwise have done it this way, 0.3333 and 0.5. Let me go and grab a calculator real quick. I'm only insisting on 4 decimal places of accuracy in this course. And you can see this is the same here because this is 0.6 with a bar over it. But to 4 decimal places, we have that. So this is the formula for conditional probability right here. And what it is, let me write the definition of it. This is the outcomes where B has already occurred. So really, we could say the probability, it's probably better to look at it like this. A/B is the probability of A occurring given that B has already happened. All right, next example, I'm going to still roll a die again. So every time you do that, you should at least have handy the sample space. You may not always be able to write it out, but when you can, it's very nice to have as reference. So here, I'm going to let A be the event of getting either a 2 or a 3, and I'm going to let B be the event of getting 2, 4, or 6. Basically, B is the even numbers there. So when I look at A and B, they have only 2 that they share in common. So now if I want to calculate the probability of A/B, that's the probability of A and B divided by the probability of B. So A and B, that was 1 out of 6, and the probability of B was a 3 out of 6. That equals 1/3, or 0.3. Let me give an explanation here. All right, since we knew that B already happened, it's like somebody rolled the die, but we're not allowed to see it, but they're giving us hints about it. Since we know that event B already occurred, since B already happened, we know that the outcome is already going to be one of the even numbers. So I know that. I know that I have 3 items, and I have to guess which of them I have. So if you look, I know that the answer is one of these 3. How many of those 3 do I have? I only have 1 of them. So A has only 1 of the 3 items. And that's one way you can think of it. I'll give you a better way, I think, later on as we do more convoluted kinds of examples. But for now, I think this will be okay. All right, here's a problem that I want to work here. Try it, 3.1. And I'm going to answer these in the blanks when I can, but for most of them, these blanks aren't big enough for what I want to do. So the sample space is all the ordered pairs of two whole numbers, the first from 1 to 3 and the second from 1 to 4. So basically what we have here is, like, this example is perfect. We have, let me click down here. So we're going to have x, y, the kind of numbers are here, and x can equal 1, 2, or 3, and y can equal 1, 2, 3, 4. So one of the things we're going to do is counting, complicated counting later in the semester. How many possible pairs are there here? There's 3 choices for x and there's 4 choices for y. So that gives us a total of 12 choices. I'll show you. I'll start off first with all of those items in S where x is equal to 1. So I'll have 1, 1, 1, 2, 1, 3, 1, 4, and that takes care of all the ordered pairs that start with a 1. Next, I'll move on to x being 2, and I'll go through the y elements. Got it. And then finally, I'll go to the last item for x, and that's 3, and I'll pair it with each of the items for y. And you can see there's a total of 12 of them if you count them all up. Now, it says, let A be the event that the sum is even. So what they're talking about is they're talking about the sum of the numbers inside of the ordered pairs. So if you look, 1 and 1 counts because when I add them together, I get 2, which is an even number. So I'll have to put A under here. So A is the collection where the ordered pairs sum up to an even number. So 1, 1, I already mentioned, is in there. 1 plus 2 is odd, so it's not in there. 1 plus 3 is even. 1 plus 4 is odd. 2 plus 1 is odd. 2 plus 2 is even. 2 plus 3 is odd. 2 plus 4 is even. 3 plus 1 is even. 3 plus 2 is odd. 3 plus 3 is even. I believe that's the last one because 3 plus 4 is an odd number. So there's A. Let me put its probability while we're here. Remember, the original one has 12 items in it. So how many items does A have? We have 1, 2, 3. It looks like 6. 6 out of 12. B. Here we want the collection of all these ordered pairs where the first number is prime. So the numbers 1, 2, and 3, 1 is not a prime number, 2 is a prime number, and 3 is a prime number. So the set of all items where the first number is prime is like this. We have 2, 1, 2, 2, 2, 3, and 2, 4. And then 3, 1, 3, 2, 3, 3, and 3, 4. Here we have a total of 8 items. So the probability of B is 8 out of 12, or 0.6 with a bar over it. So this is part C then. So that's part C, and that's part C. D is A and B, and A or B, so D. For D, I mean, we want the items that are in A and B, the items they share in common. Easiest way, I think, is to go through the items of A and just check which ones also happen to be in B. I know that anything that starts with a 1 is not going to be in B, so that takes care of that. I see that 2 is in there. 2, 4 is in there. 3, 1, and 3, 3. Of course, we'll be asked for the probability of that. So the probability is 4 out of 12, or 0.3 with a bar over it. E, I'm still on E, so I got to do A or B. So that was a part E. A or B. So this is the items that are in A and the items that are in B, or both. So like I did before, I'm going to write down all the items that I have in A. 1, 1, 1, 3, 2, 2, 2, 4, 3, 1, and 3, 3. Now what I'm looking for are items that are in B that I have not already put in. So let's take a look. Let's start with 2, 1. If you look down here, there's no 2, 1 in there, so I'm going to attach it here. Move on to 2, 2. I see 2, 2 here, and it's in here, so I'm not going to include it. 2, 3. 2, 3 is not in there, so let me add it. 2, 4. I already had it. 3, 1, and 3, 3 I already had it, but 3, 2, and 3, 4 I didn't have. So how many items do I have in here now? I have 1, 2, 3, 4, 5, 6, 7, 8, 10 of them. So there is the probability of that. That's 10 out of 12. Or as a decimal, 0.83 with a bar over it. F, B prime, and the probability of B prime. So these are the items that are not in B. Let's come up to B. Had a total of 8 items, and the sample space had 12 items. So I need here the items that are not in B. So let's start. So what I'm going to do is 1, 1. That's not in B. 1, 2. All right, so 1, 1, and 1, 2. Let me put those in there. Let's see, actually, anything that starts with a 1 is not going to be in B. So let's go ahead and put all those that start with a 1. Okay. Let's see, 2, 1 is in there, 2, 2 is in there, 2, 3 is in there, 2, 4 is in there, and 3, 1 through 3, 4 are all in B. So this is it for B prime. So the probability of B prime is therefore 4 out of 12, or 0.3 with a bar over it. This part G, you don't even need to know what A is. the probability of A plus the probability of A prime will always equal 1. Now, I don't remember how many items were in A. Yeah, this is kind of weak because A has 6 out of 12. So 6 out of 12 plus 6 out of 12. That means there are 6 items that are not in it. Clearly, this equals 1. But this formula, keep that handy. That's true no matter what the event is. And H, PA/B and PB/A. So we're going to go. The probability, we'll start with A/B. That's the probability of A and B divided by the probability of B. So let me see here. Where's my probabilities at? Probability of B is way up there. Is 0.6 with a bar over it. And the probability of A and B had 0.3 with a bar over it. And I think that you're going to find that this equals 0.5. And the probability of B/A, the numerator is the same, probability of A and B. The only thing different is the denominator. So here we have 0.3 with a bar over it, and I think A was 0.5. So let's go ahead and throw this on the calculator. If it's still up, there it is. So I get 0.66. Basically, it's going to be 0.6 with a bar over it. But we'll just do 4 decimal places is all I ever require. Here's another extended example to try to make this material easier for you to understand. We've done this before. A fair 6-sided die is rolled. Describe the sample space. Easy enough. S will equal 1, 2, 3, 4, 5, and 6. The event T, the outcome is a 2. So what they want you to do is to give the event listed as a set and give its probability. So this is easy. T is simply the number 2. So the probability of that, since there's only one item in there, 1 out of 6. Or if you put it into your calculator, 0.1, and I think the 6 is gone forever. B, the outcome is an even number. So this here, the event then, is 2, 4, or 6. And its probability is 3 out of 6, or 0.5. I'll give myself a little more room. C, the event B is that we know that it's less than 4. Less than means 4 is not permitted. We have to pick numbers that are smaller than 4. So we have 1, 2, and 3. The probability of B is also 3 out of 6, or 0.5. The complement of A. Well, in English, or in just plain language, A is the collection of the even numbers, so A prime is the collection of the odd numbers. What comes after E? A given B. So let's take a look. We know that one of these things is in here. So which of these are there? 1 out of the 3 that are listed. So that's going to be, this is strange. We want the number 2, but it's going to be 2 out of 1, 2, 3. So the probability of that, which I know it's going to ask me for it, is going to be 1 out of 3, or 0.3 with a bar over it. And if you flip it around, B/A, this time we know that the number is even. Well, how many even numbers? So we know we've got 3 possible outcomes. Well, B contains only one of those 3 outcomes. So it also is 2. But then A has 2, 4, 6. And B has exactly 1 out of 3 of those things. So the probability of B/A equals 1 out of 3, or 0.3. You should do this example also with the formula to make sure that we're getting the same answers. Make sure that you're getting the same answers. All right, let me move on to G. So what items are in A and B? So what items do they have in common? They only have the number 2 in common. A or B. So now I'll start with putting the items first in A, from A. So from A I had 2, 4, 6, and now I'll add any items from B that I have not already put in there. And it looks like I have to add 1 and 3. So its probability of A or B equals 5 out of 6. I didn't write the probability of this. Probability of A and B is 1 out of 6. So we have A or B, A or B prime. Ooh. So that is I. Well, let me first get B prime. What's B? Where'd it go? B is 1, 2, 3. So this is 4, 5, 6. So then we want A or B prime equals, all right, let's start with A. A had 2, 4, 6. Now, does B prime add anything more? I've already got the 4 and the 6, so I'm going to add the 5 in there. And the probability of A or B prime is going to equal 4 out of 6, or 0.6 with a bar over it. J. The outcome is a prime number. So we've kind of done this. 1 is not prime, 2 is prime, 3 is prime, and 5 is prime. So the probability of that n is 3 out of 6, or 0.5. And finally, K, the outcome is 7. So the letter I, here's what I'll put. None of the items in the sample space are 7. So I have what's known as an empty set. When I take the probability of I, that's 0.